Hello learners, welcome to today's discussion. Today we are going to go through a process that manufactures concentrated sulfuric 6 acid, and that process is known as contact process. The flowchart we have reads, the flowchart below shows how sulfuric 6 acid is produced on large scale, and we have already said that on large scale, concentrated sulfuric 6 acid is manufactured through a process known as contact process. We are going to start by looking at the raw materials. The raw materials for this process. Number one, we have sulfur, and this sulfur is usually obtained from Flowchart process, and this is a process that is used to extract sulfur from its deposits. Number two, we have air. Stroke, we can say from air we are going to have oxygen gas. In this process, we are going to go through the following steps. One, we are going to take the sulfur, we burn it in air for us to get a gas which is sulfur 4 oxide. Then we take the sulfur 4 oxide, we burn it further in air to give us sulfur 6 oxide. Then we take sulfur 6 oxide, we dissolve it in concentrated sulfuric 6 acid, because we cannot dissolve it directly in water since excess heat is generated which could boil the acid produced. Then after dissolving sulfur 6 oxide in concentrated sulfuric acid, we get oleum, and oleum is actually with the formula of H2S2O7. Then we take the oleum, we dilute it with water for us to get the concentrated sulfuric acid in that particular case. Another thing that we need to know, this is a catalyzed process, and therefore we use the catalyst. And the catalyst used here, is number one, we have vanadium 5 oxide, that is V2O5. We can also use platinum. Platinum is the most efficient catalyst, but we don't use platinum always. We use vanadium 5 oxide because of two reasons. Number one, vanadium 5 oxide is cheaper. Number two, it is less easily poisoned. Another thing that we need to look at are the optimum conditions for the production of concentrated sulfuric acid. And the optimum conditions, number one, we need to produce it at a temperature of about 450 degrees Celsius. And number two, we need to use a pressure of between 2 to 3 atmospheres. So let us go through the scheme together. The scheme begins from where we have solid D, and solid D is sulfur, and we have already said that sulfur is obtained from Flowchart process. We have gas E, which is oxygen, coming to the burner, so we can do an equation direct, that is sulfur plus gas E, which is oxygen, to give us sulfur 4 oxide, which is our gas F. Then sulfur 4 oxide is taken into the mixer where it reacts with more of gas E, which is the same oxygen, and taken to the catalytic chamber where it produces sulfur 6 oxide. And therefore in this case sulfur is a solid, E is a gas, which is oxygen, and this reaction produces sulfur 4 oxide, which is also a gas. That is the first equation, which produces gas F. Then we go to the mixer with our gas F, which is sulfur 4 oxide gas. We burn it with more air, or we oxidize it further into sulfur 6 oxide. Remember, this process is a reversible process and therefore it can go either way. We can balance the equation. We can balance the equation by writing 2 behind sulfur 6 oxide and 2 behind sulfur 4 oxide for the equation to be balanced. After obtaining our sulfur 6 oxide, we are going to dissolve our sulfur 6 oxide in concentrated sulfuric 6 acid for us to get oleum. And this is going to be our equation number 3, where we are going to have sulfur 6 oxide being dissolved in concentrated sulfuric 6 acid, that is H2SO4. This is a liquid. For us to get oleum, we are going to have 2 hydrogen atoms. Then of course we are going to have 2 sulfurs. Then oxygens, we have 3 plus 4 giving us 7, and that becomes the formula of oleum, which is going to be diluted with water to give us concentrated sulfuric 6 acid. That is to say, if we can do an equation for that, we are going to have H2S2O7. We dilute it with water, which is a liquid, for us to get concentrated sulfuric 6 acid, which is a liquid. And for us to balance the equation, we are going to write 2 behind concentrated sulfuric 6 acid for the equation to be balanced. Having done that, we can now go through the questions and try to answer them. Remember to subscribe to our channel and also click the notification bell so that anytime we produce a video like this, you'll automatically be notified. Part A of the question: identify Roman 1 gas E. Gas E has been identified as oxygen gas. Number 2, we have solid D, which is sulfur, and the source of sulfur is from the Flowchart process. We have gas F. Gas F is formed as a result of the reaction between sulfur and oxygen, and therefore gas F is sulfur 4 oxide. Then we go and identify substance G. Remember, substance G is what is coming into the formation of oleum, and therefore when we take sulfur 6 oxide and dissolve it in substance G, we get oleum, and therefore substance G is going to be concentrated sulfuric 6 acid. That is concentrated sulfuric 6 acid. Next, liquid H. Liquid H is the one that is taken into the dilution chamber, and for us to get concentrated sulfuric acid, we dilute oleum with water for us to get the acid that we are targeting. So liquid H is water. B, part of the question, part B of the question. Name the catalyst used in the catalytic chamber. We have said number 1, we can use vanadium 5 oxide. Because of the reasons we have identified. Number 1, we have said it is cheaper and less easily poisoned by the catalyst. Number 2, we can use a more expensive catalyst, which is platinum. But platinum, number 1, has 2 disadvantages. 1, it is expensive. Number 2, it is easily poisoned by the catalyst. Roman 2 of part B, write an equation for the reaction taking place in the catalytic chamber. In the catalytic chamber is where we are going to have sulfur 4 oxide reacting with more air to give us sulfur 6 oxide, and therefore we are going to have sulfur 4 oxide being oxidized further in air to produce sulfur 6, which is a gas. For us to balance the equation, we are going to write 2 behind sulfur 6 and then 2 behind sulfur 4 oxide for the equation to be balanced. Next, that is part C. State 1 industrial use of sulfuric 6 acid. Number 1, sulfuric 6 acid can be used to manufacture detergents. Used to manufacture detergents. Number 2, it can also be used to make car batteries. Used in the manufacture of car batteries. That brings us to the end of our analysis or discussion under the contact process. In case you have questions regarding the same, kindly interact with us in the comment section and we shall be glad to address your concerns accordingly. For those who are watching this channel for the first time, kindly take that 1 second and hit the subscribe button. And to the subscribers, we continue thanking you because it is because of you that the channel is growing.